So what are scenes and why do we use them? Well, I pose a question to you. Is automation without scenes truly automation? The goal is to do a lot with very little or to no input. But how do we achieve this? The answer is with scenes. So scenes is a really nice way to make an automated place very easy. And I thought I'd just give you this little quote about something I thought about automation and how it goes together. Automation is not about automatically turning on or off lights, but it's setting an environment to live in, cater for your health, your mood, and your well-being, involving all aspects of a building functions. A well-automated building should be dynamic, reflections of its occupants in aspect of activities, life cycles, and schedules. Automation should serve to equal parts efficiency and indulgence to more important things that in life. The ultimate building should know and set the application or the loads before the occupant realizes they are required. It should be second nature and at the ultimate intertwining of man and machine. It's all about educating the customer. So just want to take a second there. In buildings these days, we have lots of loads, complications and requirements from the customer. It's our job to simplify those and make them automated. So automated means little to no input, which means one of the best automation jobs are with less switches and less things. And the way we're going to achieve that, we're showing you today, is through scenes. Now, I'll share a little story with you about this very thing. We had a lady come in the showroom once and we could tell by the design and what she was spending that it was a fairly comprehensive job. And we immediately took her over and showed her some of the lovely switches, and one of those being Sentito. And she exclaimed pretty quickly that she absolutely loved the look and the feel of the Sentito, but it would be no good for her house. And when I questioned her why it would be no good for a house, she simply stated, I haven't got enough buttons. I'm going to need somewhere between 12 and 14 buttons. Okay. And I kind of thought to myself, this doesn't sound right. She has not been consulted or anything like that. So when I got her, I said, look, just before we start, you obviously got a fairly, a lot of you're going to put into this house. You've also got a lighting designer. She said, yes, I have. And I said, okay, let's just have a look without using the Sentito, how you would use this. And she explained, that she needed the 12 buttons for lights and 2 buttons for lights. And I said, let's just go example of how you're going to use it. So I said to her, if you came into the room, it means you'd have to adjust all 12 buttons to get the lights just right in the right kind of setting of the way you like it and adjust your blinds. Then you would use the room. And then when you walk out, you'd have to turn all those 12 back off and the other blinds and do whatever you're going to do. It seems like a real lot to do. And immediately she was, she was stunned and she said, yeah, I get what you mean. And so I said to her, what we need to understand is that you've had a lighting designer in there. They've never meant for all those lights to be on 100%. They're all meant to be in different levels to create different moods, also known as what we call scenes. So then I explained the concept of the Sentito push button, and it only has 4 buttons, and you only really require 4 scenes because when you press it, it calls a daytime scene. You press this one, it calls a nighttime scene. Or you press the bottom, it calls all off, or whatever it is. And once I explained that to her, she was much more comfier with having the use of scenes. Now, I took it a step further. I said the Sentito actually has a really nice quality, and that quality is the fact that it has a multi-touch. And so what they believe and what we believe too is that the multi-touch is what most people use. So when you're using the multi-touch, basically when you come into the room, you use the room. The switch is actually monitoring what's going on inside the room. If you're turning things on, off, dimming up, dimming down, and it's keeping a track of what's happening. Even though you're not might be using the switch to do it, you may be using your phone or some other visualization to do it. It's tracking what's happening. So when you come to leave the room, you hit the multi-touch, it makes a decision based upon what it sees you've been doing, whether you're leaving or coming into the room. And so what it does when you hit the multi-touch, it then sees that you've got some lights on, it means you're leaving, okay? So it turns everything off. If you come into the room and you hit the multi-touch and nothing's on in your room, then it makes a decision that you're coming back into the room. And when you do that, it either goes back to the state you had it, or the daytime scene, or the nighttime scene. This is much simpler for controlling of a big room, and it made a much more sense. Long story short, we sold her the Sentido and she was really happy with the functionality, just hadn't had things explained to her. We're going to look at scenes in 3 different ways that you can do in KNX and the benefits and the traps of using each of those ways. Before we get into the benefits and the traps though, I'm going to talk through basically how each scene operates and what contains in each scene. The first way we're looking at is device-based scenes. With device, it has the memory of the scene controller built into it, which has channels, and these are typically limited to 8. Each scene can have a different level for each channel, which can be configured to talk to the actual working group addresses for controlling the loads. Typically, the amount of scenes that it can call back is up to 10. When a scene is called, the devices send many commands to many different group addresses to set the desired levels. New levels can be taught into the scene controller. So just to recap that again, a scene-based or device-based scene controller lives inside a switch or some device, and it acts like a scene memory, and it stores all the information for those scenes. So you are limited to memory. And when you call a scene from it, it goes out to up to 8 different channels and tells them what to do. Now, the combination of those channels changing different levels is up to 10 scenes or 8 scenes. Okay, the second way we're going to look at is server-based scenes. So these are quite popular too. Like device-based scenes, these don't live on the, unlike I meant to say device-based scenes, these don't live on the bus. They have a lot more memory and they generally involve more functions. And they involve those functions that don't always live in KNX, so it can be quite attractive. These can be easily created with the visualization and linked to KNX inputs to trigger them. So you can build a scene within a visualization, link it to a button, and then trigger that scene. And if you think a bit further ahead, you can actually make a scene that a customer can change, and when they press the button in the visualization on the switch on the wall, that visualization can develop the scene that they've made. They're limited by the memory and how many telegrams and messages can be sent at once from the server and sent on the bus. So they do have their limitations. We're going to look at that in a sec. The last way I'm going to talk about is global KNX scenes. And with global KNX scenes, the scene memory exists on each device. In this case, you have unlimited memory, but it's very hard to manage and to set up. You need to go into each device and say what it does in each scene. It's also inherently very much more reliable, and you're not dependent on a single device. There's also lots less traffic, which is good for a big project. Basically, a scene number is called across the bus, and every device hears that, and only those that need to react to it. So in that sense, every device remembers what scene it's involved in and what it needs to do, and then the traffic on the bus is simply to a group address. We are calling this scene. Everyone subscribed to that scene that's listening to that group address will then play out their action. So really good for keeping bus traffic down, and global scenes where we are doing all on or building all off a building or whatever. Now let's look at what the benefits are and the traps of each system and each way of doing stuff. So for the benefits on device-based scenes, it's easy to manage because you only have to go to one device. It's good for a room, so you keep everything localized. Exist on one device, which means you don't have to go to multiple devices to program things. You're just looking at one device, and it can be called from many places. Okay, so you can call that same scene in conjunction with other scenes actually, and from any device it all acts the same. Server-based scenes, you get a lot more involved. So you can have things that are not on the KNX involved, along with side of things within can be involved. It's much easier for the customer to manage. And in some instances, which we're going to look later, the customer can actually create the scene. And they can always adjust what you've already done. And you can do it live as well. So you can live check on the scenes. And we're going to have a look at that in a sec. Benefits of global scenes is it's incredibly powerful. You have an unlimited memory. It's fast acting because there's only one communication going on the bus, and it's much reduced bus traffic. And the customer can save it. And I'm going to show you in a little bit how the customer can save those scenes. Now let's look at the cons or the traps that you have to make sure you know about. With device-based scenes, you're relying on one device. So if that device breaks, your scene control is gone. Okay, we've had a look before. You're limited by memory and you're limited by functions. And I'm going to show you a little bit of a video with ETS, a live thing with ETS, and showing you how you're limited with functions. You can't cover all those functions. It can be very difficult to manage because you've got to trace where the scene's coming from. There's a lot more to program, and there's definitely a lot more traffic on the bus. The traps with the server-based scenes is you're relying on a server, and you're not just relying on a server, but you're reliant on the customer's network. Okay, so it's something that may be out of our control. There's a heap of bus traffic associated with bus scenes, so sometimes that scenes can be delayed if you have really big scenes. It's not the way to do everything. You have a limited memory. Granted, that memory is fairly big on a server, and delayed actions, just like I said before, because you have heaps of actions happening at once, it's going to be delayed as it comes out in the bus. Now, looking at the global KNX scenes, you know, the traps of that is it's really hard to manage. You basically, due to the fact that KNX does not have a central processor unit that's responsible for all communications, and it's a point to multi-point system, that means that you have to go into each device and adjust that scene when you first set it up, at least when you first set it up. It's not intuitive to adjust. You need to allow for a scene matrix and everything like that, and the customer generally can't create those scenes. So when we're looking at device-based scenes, I've chosen a couple of switches to show you a little bit of how they work. The big thing you have to understand is not every switch has this scene functionality or scene device-based scenes functionality. And even when they do, the functionality differs a little bit, so it's not always consistent. So I'm going to show you for this example a Gira sensor for comfort. And I'm also going to show you the Sentido version of it, but we're going to work our way through with the Gira switch because it's kind of done nicer. So basically, we have to go through, we have to enable the scene functionality. This enables part of the memory to remember to use a scene function for memory. And if we go into the scene function, this is kind of separate from the rest of the working of the switch. It's just a part of the memory we're using. Okay, so the first thing you'll see is overwrite scene values during ETS download. So what this means is if you untick that, you can download to the switch without overwriting existing scenes. And we're going to look a little later about how you can set scenes and then customer can save their own scenes, okay? We'll have a look at that in a little bit, but just that's what the tick does. So in this example, we're limited to 8 different scene outputs, okay? And they can be depending on what you want them to do, but you're limited to 8 different functions that are coming from this scene level. So you're a little bit limited in this case. And you can see here we're also limited to 8 outputs that are involved in up to 8 different scenes. Okay? So what we have to do first is decide what the data point types are the things we're going to control. So I'm looking at controlling turning on and off some lights, and the second one I'll do is I'll put some blinds up and down, or maybe dim something up and down. The third one is I could change I can change any kind of value I want. So maybe it's mode for air conditioning. The third one could be something simple like changing the color temperature of a light, for example. Okay. So in scene 1, we're going to call this scene all off. And what we're going to do, we're going to have somewhere management in maybe somewhere else in a document or an Excel spreadsheet, what the scenes are, who's involved and what they are. And we're going to have a look at that a bit later in the webinar. So in scene 1 with all off, we're going to use scene output number 1. Yes, and the command we're going to use is an off command because it's going to be all off. Okay, we can put a delay on it. We can allow it to save. In scene 1, output 2, we're going to all the way down. Okay, so we want it to 100% down. Scene 3 for the thing is going to put it in auto mode, the air conditioning in auto mode. So then we can put that in and put a delay. And scene 1, output 4, will be going to the color temperature 2700 Kelvin. We can leave that as it is. Okay, so now for scene 2, we have to say maybe this is an all-on scene. And in that scene, we have that recognized throughout the system as scene number 2. Okay, so scene output number 1 with all on. For scene 2, we want it on. Scene output 2 for scene number 2 is going to be the blinds all the way up. So 0% is 100 is exactly right. Scene number 3, we might want it in dry mode, and I can tell you for a fact that the mode for dry mode in any aircon is number 9, or fan mode. Okay, and we want the temperature to maybe be 6500 of the light fittings. And so you go on and through and say all these scenes. Now, this takes a little bit of time, but the beauty is these can be saved, and we'll show you a little bit later how these can work. So then what I have to do is I have to go over to my linking, and I have to now connect my switching of my lights. I have to connect the up and down of the blinds to a height. I have to connect the HVAC for the mode. And you can see color temperature. I haven't got any color temperature in there, but you get what the point is. So I have to go linking all that. Now, the way we're going to control that is pretty simple. We have to have a scene group address, and I'll just close this up. So we have a scene group address, and this is called the call scene group address. So we have the input for the scene to be called. Okay, so now we have that linked to there, which is fine. It means that we can call the scene, and if we call in this scene group address 1, 2, or 3, we're going to get those different scenes. Now we have to go to any of these switches, including the device's own switch, and we have to say, rocker 1, your actual function now will be scene control. Okay, so if we push on left rocker, we want scene 1, and we push on right rocker, scene 2. Okay, and it same goes if I go to any of these other switches. So core switch, and I'll go switch configuration. We'll make a few more buttons here, and I say on the first rocker, your function will actually be a value or a scene or button orientated. So you get 2 different buttons coming out, and the actual function of that will be a scene. Okay, so we push button 1, we want scene 1, and if we push button 2, we want scene number 2. Okay, so in that way then, we can link everything where we want it to call the scene. So if I'm looking at the Gira switch, we made rocker 1 call scene 1 and scene 2. So the output for the rocker 1 is scene extension. So I'll link that to my scene call group. Okay. And then same with the Eclipse switch or the core switch. I had buttons 1 and 2 as configured to be seen. So button 1 calling scene 1, button 2 calling scene 2, and I'll put that in the same group address. Now what happens is, if I open this up a little bit, you can see that if any of these buttons call a scene, they call the scene, and then the input to the scene memory recalls what's happening on that scene. You call that scene, and it goes out to the lights, the blinds, the HVAC, and anything else you've got linked to it, and sends it to those levels. And that's how device-based scenes work. Lastly, I just thought I'd take you over what the Basalte Zennio looks like as a different option to having a centralized or a device-based scene. So in the Zennio, they're a little less involved with the scenes, and to be honest, it's not the most common way we do stuff. And what they have on board is a scene controller. And they have a scene controller on board, and that scene controller, instead of being multiple things, they've only given the option for it to be a 1-bit or a 1-byte command. Okay, so Really, it's most of what you need. So one bits can turn things on and off, put blinds up and down, do things like that. Where one bytes can do modes, uh, fan speeds, blind positions, percentages, all those kind of things. So, you know, it's not quite the same. It's a little bit less effective, and you need to know a little bit more. So, again, instead of putting the blinds up or down, we've got to put them to 50%. We've got to work out that it's 127 on a one byte command. So, again, not exclusively used. You can see here that in the scene controller, it's a maximum of 8, and then there's only a maximum of 6 scenes that can be called inside this, just so they don't have the room. So there you go. For server-based scenes, there's lots of options, and it's quite a popular option because it's easy to manage and the customer can create them. Today, I'm going to use an example of Basalte. Really like the way the scenes are done in this, and they're very easy for the customer. So I'll have a look at how they're set up, how they work, and how the customer adjusts them. So what we've got inside the software, we've got a component called the scene controller. Now in that scene controller, we can make internal scenes and external scenes. So the external scenes are scenes that we can press in Basalte and they can trigger in KNX. So if you had KNX based scenes or KNX device based scenes, then they would trigger those. Or we have internal scenes. And internal scenes means that the scene memory, the scene creation, and everything to do with the scene is created inside the server, and it can be triggered from within the visualization, but it also can be triggered through a group address that's connected to it and calling a scene from a button. So the way I'm going to show it to you, a very popular option is that you can set up a KNX network and have the switches connected to the scene group address, and you already know your scene group address through the scene management, which we're going to show you in a bit later. And then you can trigger your scenes. So this allows you to develop the scenes, connect them to a button, and then later on the customer can change what happens in those scenes, and then going forward they can change them as much as they want. So what we do, we create these scenes. I've created just internal scenes because we're looking at server-based scenes, and we've got away, cook, home, party. Now the reason I've created these ones, these are the ones I'm going to give to the customer. In this scenario, the customer can make their own scenes, but when they make their own scenes inside the visualization, they can't be linked to KNX. These ones are going to be linked to KNX because I've created the scene, I've said what the scene is, and I've got the KNX value. So I've got the scene number value, 11 for away, 12 for cooking, 13 for home, and 14 for party in the living room. So we already know now when we trigger those scenes from here that it'll trigger the away scene, whatever we create in the server. And we can trigger that from the KNX by sending it to the same group that it's attached to, calling scene group scene value number 11. So if we look at the connection to the KNX, I've just got here, I've filtered down to the living room, and in the living room I've got the scene controller. Now for the external scenes I've got a different scene group address, but for the internal scenes I've got the group address 9/0/6. So now I've linked that to the scenes. That means that any other device in the KNX network who's configured to call scenes is linked, their output is linked to that scene group address number, and they're calling scene 11, they're going to call away. They call scene 12, so exactly what you would expect. Okay. Now we'll just swap over and I'll show you how the scenes look inside the visualization. So I'm in Basalte, the application for Basalte, and this is what we come when we send the scene page. Now, these are just favorite scenes that the customer has linked, but if we go to the scene component here, you'll see that I have in that scene component, we've got our away, our cooking, our home, and our party. Now, when I trigger these, the scenes are internal to the server. However, if I want to trigger these from externally, like I showed you before, they can be linked to any switch. And this can be done before you do the scenes. So just to have a look at the way thing, the beauty about the server-based scenes, and especially in Basalte, is the customer can configure these themselves, and you can configure these for the customer very easy. So all we have to do is we have to go edit, and then we can add anything from the room. We can add the wall down lights, we want them on and we want them to 50%. Another cool thing is we can do here is we can do live adjustments. So if I click the live adjustments, then I can see exactly how I like the way. So when we've got the away scene, I know that these are going to be all off. So now I'm actually looking at the room, and the room is all off at the moment. Okay, so that's how I like the away scenes for the lights. But we can add a little delay in here if we want to make some kind of mood, or we can add some shades, anything to do with shades. So maybe we're going to close the shades, and we can do live adjustments for them. But we can do anything else that's in that room, considering TV, music, thermostat controls, anything at all. So it's in the away thing. So we're going to turn the mode off, the fan off. The set point can stay where it is. So that just gives you a bit of an idea. So then when we want to save that, we can save it, and we can actually play it from here and see what we want. And if we go and push the button on any of the switches, which are linked to the scene group address that are calling scene 11, then we'd expect to see this happening. So that means the scenes are very dynamic and the customer can change them. Again, the limitation is on how much memory the server can scenes it can remember, but it does open it up to everything else that's available on the thing. So if you have a look here when we edit it again, we can do things like TV or music, or it depends on what's involved in the server. So you could have for your party one, you might want to have, the lights all on, the music all up, your thermostat's really cold, your floor heat's off. So set points, you want to have a nice party, you're going to have people jumping and pumping. So the mode to auto and your fan on, for example. But not just that, we can have our lights, our hue lamp, for example. We want to make it a color, nice pink color, brightness right up, and then our music can be on one of our favorites streams or playlist or top weekend or whatever it is with the volume up. And that's scenes on a server based. And finally, we're looking at global scenes, or also known as KNX scenes. And the difference with these scenes is they're incredibly powerful, because what I'm about to show you is the memory of the scene is saved throughout all the devices, and to call a scene over the network is only one telegram to tell all those devices to go to that scene, to what they got to do. And so the difference is we're not relying on a server, we're not relying on a device if it breaks, we're relying on a whole lot of things. You've got all inputs and stuff. Generally, we can have one group address and that will work for most of our scenes. So I'm going to take you through each device, and this is going to be a little bit quick because we haven't got all the time in the world. And I'm going to show you how to configure the scenes and how I'd put them together. Just remember, the scenes are universal. So each device needs to know A, is it involved in a scene, B, what scene number it's involved in, and C, what it's going to do when it hears that scene number called. Okay? We can call up to 64 scenes in a group, and we can have multiple groups and multiple scenes. So when people say how many scenes can you have in KNX, it's really how long's a piece of string. So the first one I'm going to show you is just channel output, channel A, output A, sorry, on Dali Gateway. And I'm just moving through the configuration, and we're going to enable scenes. Okay, so this is how we're going to do scenes in a Dali Gateway, ABB Dali Gateway. We're going to jump over everything and go straight to the scenes. And in the scenes part, we're going to say that this Dali output is going to be involved in scenes 1, 2, and 3, for example. We'll do all 1, 2, and 3 for this example. So scene for daily scene is 2 is involved in KNX scene, and daily scene 3 is involved in KNX scene 3. Okay, so what that'll do is here, it'll give us scenes 1, 2, and 3 here. And then we can just go through and choose our groups. Choose what groups are going to react to what scenes and what brightness they are and how many what time they color, what the transition time is, and it's as easy as that. You know, you can go in here and make little adjustments to it and say, actually, I only want you to go this to 78% and maybe the color to 1500. Okay, and we can do it like that. We could have, you know, again, different daily groups involved in different scenes doing different things at all. So maybe we don't want them to all select, you know, maybe we want them all off, or we don't want them to all color change. Just depends on what you want, how you want the scene to come out. Okay, and also these scenes are savable as well. Okay, so what that means is, what I'm going to show you in a little bit is that once you write a scene, you can actually resave the level of the scene. So you get the idea that you're going forward there. That's all we do with that daily gateway. Now, I'm just going to move through the configuration of each different type of device just to show you how scenes are done differently, and then I'll show you how we link them. So I'm going to Zennio output dimmer, and basically we're going to do independent channels. And one little thing I've noticed, which some people don't realize, if you choose all these together, and you can do control, so you can go control, configure, 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 and it's not going to come up for me. Sequences. There we go. And we can choose all the sequences and scenes to go in there. Then we can choose scenes and sequences. And so this way I'm doing it just one device really quickly. And we're going to say each channel's involved in scenes 1, 2, 3. Okay? And then inside those scenes, we can say what scene number it reacts to, what sliding level or custom sequence do you want it to turn on to. Okay? So just depending on what actions it is, what it's like that way. We could also do this with a normal dimmer. So we can go into the dimmer and we can say function sets. And if I highlight shift and highlight all of them, it's going to make it much quicker. So we're going to enable all the scenes. And then when we go into all the scenes, we can say, right there, we can say what channel reacts to what scene number. So scene 1, scene 2, and scene 3. And already suggests some allocated values for that. And it's also got permitted teach in. So that's all good when we've got one device. But if we want that same scene setting across all the devices, all we have to do is highlight all of those same type devices, right click on it, which I'm trying to do, and transfer parameters and flags. Say which my master one was, which I configured, and then that's my master one. Okay. So what that's doing is transferring all the parameters, all the flags from each device. So they're going to be all exactly the same now. And you can see here where the scene settings are all the same. Okay. So that is a quick way to get them crossing. But look, let's not stop there. We can do blinds as well. We can go into, I'm just going to do one blind, for example. And we can go into the function settings and we can enable scenes. Yeah. So inside that scene, for scene A, we can go assignment with the first scene, with the second scene, and then you can see, you can choose what happens. What scene does it react to? This is channel A only, so it might only react to scenes 1 and 3. So 1 and 3 are not going to react to 2, and then you can say what height it was, what position it is, and you can put those information in there. We can keep going ahead to a Theben Zennio interface, and we can say, okay, the gateway configuration, and we can see down here there's a scene component. So we can say on scene 1, which was all away scene, we want the air conditioning. So 1, we want the air conditioning to be off, the mode to be in auto, and the fan speed to be 1. Okay, in scene 2, we can have it as cooking, and we say we want the air conditioning on in scene 2, We want it to be in cooling mode. We want the fan speed to be in fan speed 1. We want the flaps to do swinging. Okay, we can do a set point for it. We can say we want the set point to be 20. Okay, so you can see here how easy it is to configure those scenes. Now, looking at the switches in there, we need stuff to call, so I can call from visualizations. Anything that talks to that group address, which calls that scene, goes out over the bus, every device hears it, and only the ones that are involved in that scene react to it. Okay, but let's have a look at some inputs for that. So if we want to have a look at inputs for it, we can do Sentido, and I'll just do left top button, and we want it to be a scene control. Okay, and a long push can be also could be dimming, and we're going to look at that in a second, or a number of scene. So scene 1 there, scene 2 here. Oops. And scene 3 here. Okay, you get the idea. If I come to any other switch, like a Faraday switch, okay, we have a look at the scene plate, or however they've sent it out, and we just go to the switch and we say what the object is going to be. So it's going to be the scene, and we want to send single scene, or we want to toggle on and off scenes. We want off and scene 1. Or scene on is 64, scene off is 64. So there's more actions there as well. Okay, and all these together. So I'll go to a core switch. Again, we just go into the rocker. We say configuration type. We'll give it a few more rockers so you can see it's a bit more familiar. Rocker 1, we'll make it a button, and we'll make that button 1 a scene, and button 2 the other scene. Okay. So don't forget also that scenes are delivered through raw 1-byte values. Okay, so I'm going to go to this Gira switch, and for any reason, which we didn't have a scene available, which Gira does have scenes available. So looking at the rocker function, we can change that to be a scene extension. Okay, but just say you had a device that didn't have a scene extension, right? We could still use a value transmitter. Okay, and that value transmitter would be a 1-byte, and it'd be just a raw 1-byte. And the way we know what the scenes are for 1-byte, so it's a value of 0, a raw value of 0 equals scene 1. Okay, a raw value of 1 equals scene 2. Okay, so if I was to add those into the scene group address and press the button, it would send a raw value of 0 on the bus. Every device would interpret that as scene 1. Okay, so how do we get all these scenes all linked? Well, there's a couple of ways. I like to just highlight all my devices. So I'm pressing Control here, and I'm just going to select some random devices. But you'll get the idea of it. I'm just going to select some of the ones that we know that we've configured. And the best part about it, you've already done the scene control inside the switches, inside the relays, inside the dimmers, inside the air conditioning interfaces. So they can all just be linked now. And if you just highlight them all and search for scene, then you literally can pick up all these scenes, and you can do highlight. You can do highlight shift, yeah, and they can highlight all your scenes, or you can do it like the way I'm doing it, and you just choose every one of those scenes without thinking about it, pull it to the scene group address, and there we are. We've linked all the scenes in the house to the scene group address. The part that's missing out of all this is knowing what scenes are and managing it, and that's coming up very shortly. What is imperative for all jobs, and I always bang on about this, is preparation. And preparation means preparing everything so when you come to execute, you're clear, concise, and you're not wasting time. One of the big considerations, and because it's a major part of automation, is developing what I call a C matrix. Now, there's lots of other ways to do C matrices. I'm just going to show you a little hint about how you get started and show you some examples of what I'm talking about. But nevertheless, it should be documented somewhere about what your scenes contain, what scene numbers they are, what they're called, and how they for their customer. So, looking at here, I've developed just a scene matrix based off Basalte, and that scene matrix says something about the profile of the person, their streaming colors, the scene colors, because that's important to Basalte. It's not so important to KNX. And then we've got all the seams labeled in what areas they are and the scene number. So then we're unique within the KNX for the scene number. I've also taken the liberty here to draw up some of the switches and say where the scenes are located on those switches. All this documentation is really helpful, and it's imperative when you're going with big jobs, complicated stuff where you have to make changes. You need to document everything. Okay, so the hardest thing with doing global scenes in KNX is the actual monitoring of what scenes do what. And you'll find that due to the fact that KNX has not got any processors involved, which is a really benefit because you're not reliant on a processor if it falls over or something bad happens. We're actually got to manage it ourselves. So part of that management is developing not just this part of the scene matrix, but also looking at your outputs. Now, these are just examples of what you could do to develop scene matrices. So basically, we have the address of the device, our unique name for the device, the output, the description, which we've taken from the group address, and then we've said in scene 1, which is all off, what is this output doing? Or is it not even involved? In scene 2, scene 3, scene 4, and so on and so forth. And you can develop this over time, and you can use this as a template going forward for keeping an idea of what's happening in the scenes. And we can even go down as far as see what happens with dimmers and channels on dimmers and all kinds of things. So again, it's just an example. It might be blinds up, down, depending on a position, and everything that's in this containment of what you need to happen in that scene. So you can keep a track on what you're doing, and you can see exactly where the scene's meant to be and what's meant to be happening. This is really helpful when you're doing global scenes. Now, just moving forward a little bit, I thought I'd just show you how I kind of got that information. Now, it's not regimented, it's not clear how it is, but just to give you an idea how to develop the scene matrix, you have to do a bit of adjustments and stuff to make it work. But you can do things like this. We can just go to our building view and say, okay, let's just look at all our outputs. So go to my spreadsheet and I pick the channels and then I control C and that copies it to, and then I can go to my spreadsheet and I can control V and there we go. We get all the information coming out. We can take the text wrap off. We can format the width of this thing, and now you can start to manipulate it. And you might have your own description in like dimmer 1, relay 1, dimmer 2, all the rest of that. So that's one part of it. The other part of it is we could do is to the outputs as well. And this is how I developed that spreadsheet. So if I look at any one of these, for example, one of the dimmers, for example, I'll just use one of these dimmers as an example. So here we go. We've got some things hooked up to a scene. Now I've just mucked around it and I've kind of, I can actually highlight more dimmers here. So I can highlight more dimmers and I can actually start to filter, and I might be filtering with all the switching on and off values. Okay. So really quickly, I can have all these values. I can highlight them all. And if I do the same thing, Control C, and I come back into my spreadsheet, I can come in here and I can Control V and I can push them all into the spreadsheet. And that makes it easy to manipulate them later and use them how you need them. So the next part is customer scene management. Now, a real beautiful part of KNX means that not only you set scenes, with global devices or even any which of the three ways we've discussed. But we can actually also save scenes, which means once you've left the customer with a scene, they can actually call that scene, individually adjust it from other switches or visualizations or other things, get the scene the way they like it, and then they can it's usually a long push on that same button, which tells every device, including uh, servers, including device-based scenes, including global scenes, to please resave their levels. So going forward from there, when you press that button, that new level will be known as the latest scene. So I thought I'd just take you through a little bit of where we find this information. So I'm looking at just a demo from Zennio here, and you can see after download, you can go keep save scenes. Okay, so what that means is if we go into the scene channel part of it, we can actually see the configuration of it and the scenes, and you'll see here on the scene sequence, can that scene be saved? Okay, and if you go into the Theben dimmers, the same thing. You'll see in their scene sections where scenes can be saved. Okay, so you can see here, can it permit the teaching? Yes or no. So if you don't want it to resave its levels, you can do that. So how do we look on the outputs? Well, it looks something like this. If we go to Basalte Sentido, I've chosen the left function of the switch to be a short push to be throw a scene and a long push to throw a scene. But instead of the scene, I've made it about 3 seconds, so there's no chance of people accidentally getting it wrong. And so what they do is they push the first short push and it'll call scene 1, okay? If they press and hold that scene for more than 3 seconds, then it's going to call to save scene 1, okay? So because I've got the chosen scene thing. And this is pretty standard across all KNX devices. If you look at Faraday, they've got a very similar thing. You'll see here that in their part here, on the top button here, we can see the functions of the scene, the toggle of the scene, and then a long push will save those scenes. Okay, so same with any of the buttons. This is also very helpful if you're doing a handover or a commissioning and you have a lighting designer in there. So basically what you can do, if you don't have that scene save function automatically written into the switches or available for the customer because you're a bit worried about it, what you can actually do is you can actually sit here with your ETS, or you can create a page on your visualization which has this button already done on it. And so then you're going through with the lighting designer, the architect, and you're adjusting light levels to match their scenes, and or not just light levels. We're talking blinds, we're talking air conditioning, heating, cooling, whatever it is. So you can go into that room, enable the scene, see what happens. Okay, so we can do it all from ETS as well. So I could actually write scene 1, okay, and then we see what the scene happens. And then we go and adjust that scene by means of pushing a push button or visualization or some other means of individually controlling all the components in those scenes to the levels that you now want. And then you can come back in here when the designer or the influencer or the architect says, that's how we like it. Then you can come back in here and say, I want to store that scene, press go, and that will then store that scene. It'll tell all the scene controllers, the scene-based devices, and the scenes in the KNX devices to please remember next time we call you for scene 1, your current level. This brings us to our final segment of this webinar, and that is looking at control, dimming, and scheduling of scenes. So it's no real big secret that we're creatures of habit, and we do the same things every day in and day out, day in, day out. And once we get used to scene control, it's a very powerful thing because we're doing a lot of actions depending on one input, okay, which is coming from the same thing. But we've got to start expanding what we do with automation. You know, what is even a step beyond that for automation is the house not even having an input, it just knowing what you're needing depending on what the time of the day is. Whether someone's home, due to they can tell if the phone's home or not, geolocation, or if the house is armed or alarmed, or if it's winter, or if it's cold, or if it's sunny, or if it's humid, and making things happen automatically. Okay, so the first part of looking at this is the dimming part, and in my opinion, there's two particular switches that do this particularly well. It is previously been able to do, but this has made it much simplified and easier. And the first one is the Basalte switches, and so they have this ability for you to be able to choose two short push and a long push. And the two defining parts of that is you can call the scene on a short push. So the customer walks up, presses the scene. The beauty of that, because scenes are very linked to lighting control, and it's very nice to have that set, being able to control it a little bit, they have on a long push a dimming control. So that same scene that you set, you can set it by pushing the button, and if you long push on it, you can dim it. You can dim it toggle up or dim down. Toggle means dim down, dim up. The other one that's adopted this kind of philosophy is Faraday. So Faraday, I'll just oops, sorry. So in Faraday, we've got the same thing happening here. So we click on the switch, we can choose the function to be a scene, and if we choose what scene to be pushed, then we can have a long push, a single button toggle. So it's the same thing. Short push calls the scene, which is great, and then a long push will look at dimming that same scene. The second part I want to talk about within scheduling scenes is a really important one, and I think it's probably a defining part of what Basalte does really well. And that is, we already saw how we could go in here and create these scenes, and the customer can manage these scenes. And the beauty of is they can change what happens in those scenes, and they can be reflected on the switches as well. And we already looked at that. But a powerful thing which I think gets eliminated a little bit is scheduling the scenes. Okay, so you know, like I said before, we're creatures of habit, and you know, we can create these scenes to happen at times where we don't even have any input. And all we can do in the logic, we can block the scene from happening if you're not home or your place is armed or alarmed or something like that. But very simply, the customer can come in here, or you can do them for them, and you can schedule these scenes. Okay, so you can create a new schedule, and that schedule might be starting at sunrise or sunset's a good one, and you can say when, how delayed from sunset or how before sunset it happens, and then you can say what days of the week you want it to happen. So you know, typically we've got a working week here, and then we can choose the scene to happen. So it might be a dinner scene. It's going to start on maybe 60 minutes after sunset, and then the scene will happen. And this is a really powerful way that customers can control their scenes. They can use less inputs for their scenes. And this is just one way of showing you how scene control works.